Hi, neighbors. This is Marie from Nextdoor, and I'm here with a very special guest today. I'm here with Dr. Nikhil Arora, an astrophysicist from Queen's University, and he's here to answer your top questions about the total solar eclipse happening this upcoming April 8th. Welcome, Dr. Arora.
Yeah, thank you for having me.
We are here to dive into the questions that were submitted to us from across Ontario. But before we do that, can we start by just understanding what is happening this April 8th and why is it such a rare and unique event?
On April 8th, there's a total solar eclipse happening. And the idea behind the total solar eclipse is it's just a coincidence. There is no actual science that goes into a total solar eclipse. It just so happens that three bodies, the Earth, the Moon, and the Sun, come in perfect alignment with the Moon in the center so that the Moon can block off the Sun's light. It also just so happens that the Moon is just big enough and just far enough away that it's roughly the same size as the Sun in the sky. And all of these coincidences make it an event that is rare enough and temporary enough or short enough that our curiosities peak. That's the reason why this is a rare thing. So what ends up happening is that once the Moon actually covers up the Sun, it actually, if you are in the path of totality, like we are in southeastern Ontario, it actually gets dark for a brief period of time. So you're able to see stars and planets during the daytime.
Very interesting. So you mentioned we're in the path of totality. So can you explain what that is?
Right. So if you think of the Sun and the Moon, Sun is the light source. If you basically think about it, if there are places where the Moon actually covers up the Sun, but not completely. And so those are called parts of partial eclipses, where you actually see cookie bites taken out of the Sun, but it's not completely covered. But there are special places on this path of the eclipse, running all the way from Mexico into US and then into Canada, where the Moon will completely cover up the Sun. And that is called the path of totality.
Amazing. Okay. So if we miss this one, when's going to be the next opportunity to be able to see a total eclipse?
Right. So it depends on where you are. If you want to stay here in Canada, if you want to stay here in Kingston, the next one passing through Kingston is going to be in 375 years. So that's going to be on August 2nd, 2399. I think I have a dentist appointment that day, but I need to check my calendar. The next total solar eclipse passing through Canada is going to be in 2044, but you will have to find yourself in Alberta to be able to see that. So for an average person who does not necessarily travel a lot, these are definitely once in a lifetime event.
Okay, so we definitely don't want to miss this one.
Nope.
All right. So let's dig into these top questions that came in from the neighbors from Ontario. So the first thing that came up was, how do we watch it? We heard that it could be dangerous for our eyes. So we'd love to know, why is it dangerous and how do we watch it safely?
You should never be looking at the Sun. The Sun is actually way too bright for our eyes to actually be able to see it properly, right? And if you ever have tried to look at the Sun, just in case, we have reflexes built in us that prevent us from damaging our own eyes, right? You squint, your eyes get watery, and then you have just a quick reflex of looking away. That's built in us so that we don't necessarily look at the Sun and damage our eyes. The issue with the eclipse is that it's something cool that's happening in the sky, and we are curious people. So we want to look out and actually experience it. The idea behind the Sun damaging your eyes is that our pupils are basically buckets, and these buckets collect light that are then processed by our brains to actually make sense of our environment. Now, the sizes of these buckets changes depending on the environment we are in. So if we're in a dark room, our pupils really expand so that they can let in as much light as possible so that we can actually see in the dark. That's why when you have slightly dark rooms, especially at nighttime, you are able to make out things. It's because your pupils have expanded drastically so that you can actually they can actually let light in. When you're in bright settings like we are right now, we don't need that bright expanded pupil, so they actually dilate or contract to limit the amount of light coming in so that you can still make sense of the surrounding, but you're not overflooded by light. What happens during totality or during a total solar eclipse is that the Moon completely covers up the Sun, so it gets dark. So your pupils expand to let light in, but the Moon's moving at 2,200 kilometers an hour, so it really quickly moves out of the way, and then it gets brighter really quickly, and your pupils don't have the time to adjust. And so you let a lot of light in, which can damage our retinas. Another issue to add to that is our retinas don't have pain sensors. So you can damage your retinas, but you don't find out until it's too late. That doesn't mean it's not something you should experience. It just means we need to do it safely, right? So we are making Eclipse glasses available to everyone, and you can use these Eclipse glasses to actually look at the sun with safely.
Perfect. So where can people find these glasses?
So if you're here in Kingston, if your kids go to school or if you work at a school, we're giving glasses, one per person, to every kid and every staff member at schools. If you're not in Kingston, if you're in other regions, I would say consult your public libraries. They should certainly have some for you.
Perfect. So if people are finding glasses online, how do they know if they're real or if they're fake?
So these glasses have to certify a particular transmission requirement or a safety standard. And that safety standard is decided by ISO, which stands for the International Standards Organization. And it is the safety standard of ISO 12312-2. So whenever you get your glasses, you should turn them around and it should say conforms to and meets the transmission requirement of ISO 12312-2. And then the next important thing is that wherever these glasses are actually manufactured, the address of the glasses should also be on the glasses as well. So if you find these two things there, then these glasses are most likely safe. One big thing I want to point out over here is that we don't recommend buying glasses off of Amazon. And the reason for that is you can't guarantee whether they meet the ISO standard or not. And it's actually quite a complicated experiment to do. So even within the Department of Physics, we don't have elaborate equipment to actually test out individual Eclipse glasses to understand whether they're safe or not.
And we're also wondering, is it safe to film the eclipse with our phones? Or could that also damage your camera?
So the sun is also too bright for your phones, just like it is too bright for your eyes. You will have to play around with the settings in your phone to be able to safely or to be able to photograph the sun. Otherwise, what it will do is it'll overbleed the pixels and some of the pixels might die. You will never find out. And that's the funny thing, because you have millions of pixels on your phone sensor that actually work through. So if some of them go, you don't find out, but you're certainly damaging your phone camera. If you're using DSLR cameras or using telescopes, you need to have solar filters on them.
Okay, that's good to know. We also got a lot of questions in regards to pets. Is there any caution that we should be taking in regards to our furry friends?
Right. So unlike us, our pets or our furry friends actually are not curious enough to actually look up. So if you don't do anything to them, they won't actually do anything. However, we are advising to keep them inside just in case. Just don't pick them and point them to the sun. I think that's the most obvious thing.
Okay, that makes sense. And let's say that it's a cloudy day or a rainy day. Should we be giving up on this eclipse?
So if it is a cloudy day, it will get clear. Do not lose hope. So what ends up happening is a process called atmospheric inversion. So the sun is not only the source of light for us, but it's also the source of warmth. So when the moon covers it, the temperature drops very quickly. And so if you're in the shadow of the moon, everything starts to cool down. But think about it, the shadow of the moon is only 250 kilometers across. And there are places on the earth that are still getting sunlight. So hot air from there rushes into the shadowed parts and actually starts to rise up, and that clears out the clouds as well. So it can clear out if it's a cloudy day. If it's a super thick cloud cover, it probably won't clear out. If it's raining, it won't clear out. But regardless, it will still get dark if you're in the path of totality for 3 odd minutes. So I will highly encourage clouds, rain, snow, whatever, you step out for those 3 minutes and actually experience that darkness, because it is profound regardless of whether it's a sunny day or not.
Well, that's great news. Let's stay positive. Thank you so much for joining us. And I wish everybody a wonderful eclipse.
Yeah, thank you so much for having me.